Today we are going to discuss about the topic differential equations of first order and first degree. What do you mean by differential equation of first order and first degree? An equation of the form dy by dx is equal to f of xy is said to be a differential equation of first order and first degree. See, what do you mean by order of a differential equation? See, if the equation have order in the represents, see, always will be considering a function y equal to f of xy, whose first order derivative is dy by dx, second order derivative is d square y by dx square. So, order of that derivative represents the order of the given differential equation, and among which is the highest order present in the equation, that will give us the order of the entire differential equation. So here we could see that dy by dx is the highest order derivative present and its order is 1. And the power of that order is 1. So the degree of the equation is also, we could say, it is equal to 1. Now the general solution. When you solve this equation, we will be getting a general solution. If the equation of first order, first degree we solve, then we will be getting a general solution with one arbitrary constant. So a solution is a relation connecting x, y, and c. So it takes the form a function of x, y, c equal to 0. There are many methods of solving differential equations, among which few are variable separable, homogeneous equations, linear equations, and exact equations. Today we are going to deal with variable separable method. So what do you mean by variable separable method? If a differential equation can be expressed as the coefficient of dx a function of x alone and the coefficient of dy a function of y alone, then we can call it as a variable separable form. So the general form takes the form some function of x into dx is equal to another function of y into dy. The general solution is obtained by direct integration. So it takes the form integral of f of x dx is equal to integral of g of x dy plus a constant. So let us look into some examples of variable separable form. One example is x square plus 1 into dy by dx is equal to 1. When you observe this equation, you could see that dy can be separated on one side of the equation and all the x terms can be separated on the another side of the equation. So when you rearrange, you can write it as dy is equal to dx divided by x square plus 1. Another example is secant square x into tan y dx plus secant square y into tan x into dy equal to 0. So how do you make the terms separately, x on one side and y on other side? If first of all, you can take the one of the term of the LHS onto the RHS, and we can go for cross multiplication to separate the variables so that this equation can be rewritten as secant square x into dx divided by tan x is equal to minus of secant square y dy divided by tan y. Let us look into one example, one question. We can solve it based on the variable separable form. The question is solve xy dy by dx is equal to y plus 2. So here we can first try to separate the variables. Once you separate it, you could see that the RHS is y plus 2. You can make it as one single unit. Take on to the LHS. So y divided by y plus 2 into dy is equal to 1 by x into dx. So now we could see that a y terms on one side and x term on the other side. So we can take up the solution method. Just do the integration to get the solution. So integral of y by y plus 2 into dy equal to integral 1 by x dx plus c. But you see the LHS is a function which is improper. So first, before moving into integration, we have to make that fractional term into a proper fraction. So how can we do the proper fraction? You can see the denominator is y plus 2. I'm trying to make a rearrangement on the numerator. I'm just adding and subtracting 2 so that it can be separated as y plus 2 minus 2 by y plus 2 in the integration on the LHS. So once again, we can separate the terms now. It is 1 minus 2 by y plus 2. So that the integral of the LHS with respect to y is equal to integral dx by x plus c. And now you can go for integration. All the terms are in the standard form. So integral of 1 with respect to y is y, and minus 2 you can take outside the integration. So it is 2 times integral log y plus 2 is equal to log x plus c. This is the required solution for this question. Thank you.